Hello everyone, this video is about the gossip protocol in distributed systems. What is the gossip protocol? The gossip protocol is a communication protocol used in distributed systems to spread information or data across a network of interconnected nodes. It operates by each node randomly selecting a few peers to share information with, and these selected peers then propagate the information further to the other nodes in the network. This decentralized approach allows for efficient dissemination of information, high scalability, fault tolerance, and eventual consistency across the network. Epidemic algorithms. Easy to deploy, robust, and resilient to failure, epidemic algorithms are a potentially effective mechanism for propagating information in large peer-to-peer systems developed on internet or ad hoc networks. The term epidemic protocol is sometimes used as a synonym for a gossip protocol because gossip spreads information in a manner similar to the spread of virus in a biological community. Importance of gossip protocol in distributed systems. Scalability. In the case of large distributed systems, keeping a centralized master node registry or directory can seriously degrade the performance of the whole system, thus making it a bottleneck. As a result, systems become capable of scaling much more efficiently. Fault tolerance. Nodes communicate with each other to broadcast messages and exchange information regardless of whether or not a node fails. In such case, node self-healing comes into play and gossip is transported across nodes who maintain the network. Adaptability to network changes. In the case of dynamic network, where nodes are often joined, left, or change the network, the gossip protocol can manage these changes very quickly. Nodes still pass information to each other across altered topology. Next importance is for eventual consistency. Gossip protocols typically achieve eventual consistency, meaning that all nodes will eventually converge to the same state or view of the information being disseminated, even if there are delays or failures in message propagation. Low overhead. A gossiping procedure usually has lower communication use. Either each node only needs to interact with a set of randomly selected peers, or a cluster features completely randomized peer-to-peer communication. This leads to a multi-fold reduction of the network traffic from a centralized registry or broadcast to all nodes. Next, characteristics of gossip protocol. First characteristic is decentralization. Gossip protocols function without a central authority and instead use communication among nodes in distributed network to enable the peers to share information. Each peer independently decides upon the partner contacts to share information, resulting in dissemination of the data in a decentralized manner. Probabilistic selection. Picking communicating parties in the case of gossip protocol is oftentimes done either randomly or probabilistically. This randomness is critically important feature as information spreads swiftly within the network and no communication bottlenecks form. Next characteristic is asynchronous communication. Nodes operate under gossip protocols are asynchronous, and as a result, they can gossip with each other anytime without any globally coordinated scheduling. Such a dissimilarity makes space for the flexible communications means and for their resilience to the network failures. Working of gossip protocol. First point is, first it will be selecting the peers. In a gossip protocol, each node chooses randomly few other nodes from the network to communicate with. The number of peers selected for communication can vary depending on the protocol and the network's characteristics. Second, information exchange. After selecting their peers, nodes exchange information amongst themselves. Exchange could involve sharing what the node has locally with those chosen peers, receiving from them, or doing both. Propagation. As long as nodes keep on gossiping each other, this will result into distributed propagation of exchanged material to all parts of the network. Once a node gets new information, it may also gossip with different nodes, thus spreading the materials farther away. Fourth step is iterative process. That is, gossip protocols usually work in iterative manner where new peers are chosen periodically by nodes for gossiping and exchanging of information. In this way, an iterative process will ensure distribution of data throughout all parts of the system over time. Convergence. The repeated interactions among nodes through gossiping eventually make all pieces of shared knowledge reach all parts connected, leading to convergence. Every single node ends up having its own part of shared knowledge finally after going through these stages. Membership management. Membership management is by maintaining an accurate and consistent view of the membership status of nodes within the distributed system. Each node periodically selects a few random peers and shares its current membership list. These peers then propagate the membership information further to other nodes in the network. Through this decentralized exchange of membership updates, gossip protocols ensure that all nodes eventually converge to a consistent view of the network membership. This approach provides fault tolerance, scalability, adaptability, making it well suited for dynamic and large-scale distributed environments where nodes can join or leave the network dynamically. Next is the epidemic algorithms. In distributed systems, epidemic algorithms involve nodes randomly exchanging information with their peers, similar to how individuals in a population spread a contagious disease. Random exchange of information. In gossip protocols, each node periodically selects a few random peers to share its current state or information with. These selected peers then propagate the information further to other nodes in the network. Iterative process. The exchange of information occurs iteratively with nodes continuously gossiping with their peers. Over time, this decentralized exchange of information ensures that all nodes in the network eventually converge to a consistent view of the distributed data or system state. Achieving eventual consistency. By leveraging epidemic algorithms, gossip protocols ensure eventual consistency in distributed systems. Despite the randomness and probabilistic nature of information dissemination, all nodes eventually reach a common understanding of the system's state. Fault tolerance and scalability. Epidemic algorithms play a crucial role in achieving fault tolerance and scalability in gossip protocols. The decentralized and probabilistic nature of epidemic algorithms allow gossip protocols to effectively disseminate information even in large scale and dynamic environments where nodes can join or leave the network unpredictably. Adaptability. Gossip protocols dynamically adapt to changes in the network topology or membership. New nodes joining the network can quickly disseminate their information to other nodes, and departing nodes are eventually removed from the communication pool. Scalability and fault tolerance of gossip protocol. 1. Scalability. Decentralized communication. Gossip protocols facilitate decentralized communication among nodes in a distributed system. Minimum coordination overhead. Nodes only need to communicate with a subset of peers, allowing the system to scale to a large number of nodes without a significant increase in communication complexity. Adaptability to network size. As the network grows or shrinks, nodes dynamically adjust their communication patterns, ensuring efficient dissemination of information regardless of network size. Efficient resource utilization. Gossip protocols distribute the workload evenly across the network, minimizing unnecessary message exchanges and conserving bandwidth and computational resources. Second is fault tolerance. Decentralization. Each node independently participates in the gossip process, allowing the system to tolerate failures of individual nodes without affecting overall system operation. Redundancy. By randomly selecting peers to exchange information with, gossip protocols spread data redundantly across the network, reducing the impact of node failures or message losses. Epidemic speed. The epidemic-like spread of information in gossip protocols enhances fault tolerance. Even if a node fails or becomes unreachable, information continues to spread through alternative paths via other nodes, ensuring that the system remains resilient to failures. Next will be self-healing properties. Nodes continuously exchange information with their peers, enabling the system to detect and adapt to changes in the network topology or membership dynamically. Eventual consistency. Through periodic gossip exchanges and reconciliation mechanisms, nodes converge to a consistent view of the distributed data over time, ensuring fault tolerance and data integrity. Thank you. These are the references used for this video.